Hi everyone, welcome back. And now we're going to go more into the blood pressure. So what occurs inside of these vessels? So we talked about the general anatomy and also the overall makeup and histology of these vessels, but what actually occurs inside these blood vessels? So what we have here, or actually let's cover some of the vessels. So we did cover the major like we covered the aorta, the major branches of the aorta, but now let's talk about these other vessels as well. So before we continue, let's talk about muscular arteries and vasoconstriction. So what is vasoconstriction? Well, when you see that prefix or root word vasal, V-A-S-O, you think of a vessel. Constriction means you're kind of squeezing, right? Like a boa constrictor squeezes its prey and food to digest itself, or not digest its food. So vasoconstriction is when you have a blood vessel and then the inside of the blood vessel ends up constricting like this. So what does that do to blood pressure? Well, again, what if you have a ketchup bottle and you squeeze it? That increases the pressure inside the bottle, so then the ketchup is going to squeeze out, right? Well, same with the blood vessels and vasoconstriction. When you squeeze a blood vessel, it increases the pressure, thereby increasing flow. Or another example. So if you had a backyard or you played with a garden hose as a kid, you know what happens when you have a hose and then you slightly cover that opening. So what are you doing? You're actually narrowing that opening. But what happens to the stream of water going out that hose? Well, what happens is that if you decrease that diameter, then that increases the pressure, right? So when you have a smaller vessel diameter, that kind of generally increases the pressure because again, why? If you have the same amount of flow, you're trying to force the same amount of water, but through a smaller opening. So you have to increase that pressure. But with a larger vessel diameter, what happens when you relieve that pressure? Well, now that's going to relieve the pressure, so you have less pressure when you increase the vessel diameter. So that's the general relation between smaller vessel diameter and pressure. Now, some of you might be thinking, well, what if we make the vessel very, 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 very small? Does that increase the pressure? Behind the constriction, yes, but in generally what we see here, if as long as you maintain a certain, it's kind of like a fine balance. You want to constrict, if you want to increase blood pressure, you can constrict the blood vessel, but not so much that the blood vessel has to cut off completely. So another thing about vasoconstriction, it also is how your body is able to redirect blood where it needs it the most. So the cool thing about vasoconstriction is that if you don't need blood going to an area, and you actually want to shift that blood and shunt it somewhere away where it's more important, you can constrict the blood vessels where it's not needed, and thereby diverting the blood to where it's needed. So things like sympathetic activity. Hey, remember sympathetic activity, the fight or flight thing? So, what happens with sympathetic activity and your digestive tract? Well, the thing is that when you're doing that fight or flight, you actually don't need to digest what you just ate. The more immediate thing that's causing the stress response, that's what you need to handle. So, what it's going to do is constrict the vessels that lead to your GI tract. It's not really important to digest whatever you just ate. So, it's going to decrease the blood flow to the various organs of your digestive tract or your gastrointestinal tract by constricting those blood vessels and shifting that blood to where you need it. Well, if you're doing the flight part of fight or flight, what are you doing? You're running away, you're using a lot of skeletal muscles and burning up a lot of energy. So you probably want to shift that blood away from their digestive organs and shift it to your skeletal muscles that are doing all that work, right? So this is why vasoconstriction is more than just about increasing pressure. It's also about putting blood where you need it the most. So this is what happens with sympathetic activity. Sympathetic activity is going to cut off these routes that lead to your GI tract, whereas it's going to divert all the blood that would go to your GI tract to your skeletal muscles that you are using to deal with that whatever's triggering that sympathetic activity. Now, another thing that vasoconstriction you might use it for is thermal regulation. So maintaining appropriate body temperature in the various parts of your body. So remember that 92% of your blood is water and water retains heat. So if by distributing your blood, you're distributing heat throughout your body. So again, since water absorbs heat, in cold temperatures, what happens? Well, you're going to constrict your blood vessels in your extremities. And why is that? Well, by constricting it from your extremities, such as the tips of your fingers and your toes, it's going to shunt the blood toward and concentrate more toward your trunk and what's in your trunk and you have all your internal organs, or even most importantly, your brain as well. So by moving your blood away from your arms, away from your legs, and towards your trunk and your brain and head, you keep your internal organs warm. Unfortunately, you might lose a toe or finger in the process if you stay in this cold temperature unprotected for long enough. But this is why we get frostbite, because again, your blood vessels are constricting in these areas that are distal and away from your trunk and head. So this is why you see this loss of color, and if you're there long enough, then these cells start dying. So this is again why people with extreme frostbite, they might lose a finger or toe, or maybe a phalanx or two. Okay, so again, what are you going to do? Decrease blood flow, that's why we see that loss of color. And why? Because we want to keep our internal organs warm. Keeping your organ is more harmful to your health to lose something like a lung or one of your internal organs or part of your brain than it is to lose a finger or a toe.